Hello. In this video I continue a little bit. Previous video was interrupted and was incomplete about those subdivision surfaces in my Tripscode program. And Tripscode is a freeware project. And what we are talking about is subdivision. And here I made a cleanup version of subdivision, and it constitutes two new methods for those subdivision surfaces in regards to patches that and I show this drawing here also you to remember what it is about. And it is about this method to find those A, B, C, D, E. There's a certain cross line for this point C, and the C gets its elevation from A and E, and to come up with A and E, this includes inside navigation inside the subdivision surfaces. And it also means that the subdivision surfaces are highly organized through the subdivisions. And now let's continue this little review, and this is about the function that subdivides further. And as you see here, I have this program running, and one object is subdivided here with curves applied to it, and those curves make those patches into curve surrounded patches, or if any curve touches those patches, then the polygon becomes also a patch object. And this one is the formed object already, but if I go into bind mode, then I should be able okay, it didn't update. Right, I just try to update this way. We see here a geometric body, and it has also an animation possibility in this program. For instance, a cinematic chain is here, and if I with L I press, then I get off those locators, and I can see this geometric shape with the subdivision here, and it has those curves here, for instance, let's say so. And if I press Alt P, then it switches the subdivision surfaces into another mode, and then it is smoother. Then the curves get traced, but in between surfaces and interpolated as a Catmull-Clark subdivision. And for those curves, they are useful to come up with the different shapes and designs. And I can, for instance, select curve and press Ctrl C here in curve mode, and Shift E, and I can adjust the shape of this subdivided geometry, for instance. And I just quit this program right now. So this is a free project, and it is not as polished user experience somebody can expect from a commercial product or something. But it's anyway, it has workarounds, and I have tried very much to minimize those bugs that are found in when you develop a program. And here the latest update was this cleanup code, and here in the subdivision starting from level 1. Level 0 is another function, and this underscored version is starts subdividing level 1 geometry, and starting from level 1 subdivides level 0 geometry and starts at level 1 this function. And then we saw that this geometry is already subdivided. Say that this is a cage, and these subdivisions are level 0, and further subdivisions that we see here are level 1 subdivisions. So 2 levels of subdivision are implemented for patches, and the higher subdivision levels then fall back into a Catmull-Clark version of it. However, they get the curves in place when they are weighted. And this is about this C point here, the video, and how it finds through the navigation those A and E points, and how this in theory it could be repeated for further subdivisions also. Let's say imagine here is a point here between B and C in further subdivisions, say level 2 subdivision, then the line we are talking about goes here through this line, and this is the same, basically the same line as this line A, B, C, D, E. Then here are points in the center of those polygons, and also 5 points are in the row, and for every those inside edge cases. But this had many complications because I couldn't figure out what is the elevation for those further marked points, and that's why it is rather difficult. And if it's difficult, this means also it's slow when you write even more code, and it becomes rather clumsy and unreadable and impossible to understand. But let's sort out this first case of this 5 points occasion here, and let's see what it looks like in code. And this is then I shortly explain what is going on here. First off, we see that each vertices are scrolled through the loop, and for every each vertex here we see it tests if it this vertex belongs to an edge that has a curve influence to it. This ES term talks about it, and the second term is for the to constrain the subdivision levels for patch algorithms for only 2 first levels, meaning level 0 and level 1, and higher levels get skipped and go into Catmull-Clark subdivision. And this is the first block of it, and if it's not, then it means it's an inside edge. And this inside edge is an interesting thing, that those inside edges start after the inside vertices for those edges start after the, so to say, it is computed based on the organization of those subdivisions. And then it goes into this finding this crossing for those 5 points, and figures out where those points lie. And interestingly, it doesn't crash, and it doesn't produce false results also. It works, and it works because also those curve influenced edges are found before those edges that are the inside edges because of this term. And this term states that edge count for previous level minus quad count of previous level, and this is the E, means those edges are scrolled for previous level, and for every edge then the center vertex is also found here with V. And this term is a little bit smaller if we observe this term than the previous the complete sum of the previous level edges. This term and those terms are identical, but the second term is subtracted for the amount of quads, and those quads equal to the inside edges that are produced for those edges. If we observe this point again, then we see that those inside edges, they are equal to the Bolu edge counts. When we see this is a quadrant, then we get 4 inside edges here, and those meaning those inside edges that are added to the subdivided edges. First, in edge arrays we get those subdivided prime edges, and then the inside edges follow in the array, and thus we can subtract from the whole edge count those quad count, and then we get a term that starts counting those inside edges. And this is basically the same thing that we can say in many ways. We can make things happen when we get these higher organizations, and here it goes, and then here is the Catmull-Clark version of subdivision, and finally we get those edge and vertice vectors here.